Hello, here is my solution to question 1b of exam paper from December 2020. So here we have a function of two variables, and in part A, we need to sketch the level curve of this function, which I'm not going to explain how to do because students asked me to record a solution of part B, right? So in any way, so what I did, I just plotted the level curve in Desmos calculator. So that was an easy thing to do. And now let us look at part B. So in part B, we need to find the rate of change of this function at the point -1, 2, right? So here is the point in Desmos calculator, the point P, -1, 2. So let me hide the level curve. And so we need to find the rate of change in the direction PO, where O is the origin. So in other words, so we need to take the direction from the point P to the origin. And the question is F increasing or decreasing in this direction? And I guess to figure out whether F is increasing or decreasing in this direction, we can just look whether the rate of change is positive or negative. So that's not really very hard. But first we need to find the rate of change, right? And to find the rate of change of a function in the direction of a given vector, what we do is we take the dot product of the gradient of the function with the unit vector that is parallel to the given vector, right? So in other words, so let me write it down here. So we need to find the gradient. That's the first step of the function. So the second step is to find the unit vector in the direction of PO. And then the third step is to calculate the dot product. Okay, so let's do that. The first step is to find the gradient vector. So how do we find the gradient of a function? Is just the vector of its partial derivatives, right? So the function is 4 times x minus 2 squared plus 9 times 1 minus 1 squared. So its partial derivative with respect to x is going to be the first term contains x. The second term does not even contain x, so it's going to be just 8 x minus 2, as simple as that. So fy, the partial derivative with respect to y in the is going to be 18. Oh wait, xy is going to be 18 times y minus 1, right? So these are partial derivatives. Well, and we need the vector of partial derivatives at the given point. The given point has coordinates -1, 2, so we need to find fx at -1.2, and it's going to be -24 apparently, and fy at -1, 2 is 18. Right, so the gradient vector of our function at the given point, at the point P, is -24, 18, right? So the gradient is found. So now we need to find the unit vector in the direction of PO. So first, what is the vector PO itself, right? So PO. So PO is the vector from P to O, right? And in order to so here you need to imagine that you want to move from the point P to to the point O, and in order to do that, what you do is you take one step to the right, and then you take 2 steps down. it. So basically, that's what you want to do, to move one step to the right and 2 steps down. So which means that the vector PO is 1, -2. All right, but then the vector PO itself is not a unit vector, right? So we need to find a unit vector parallel to it, so that points in the same direction as PO. And to find the unit vector, we need to divide the vector PO by its norm or its length, right? So we need to find the norm of the vector 1, -2. So how do we find the norm of a vector? So we take the square root of the sum of squares of its entries. So 1 squared plus -2 squared. So which is square root of 5, really, right? So just the square root of 5. Right, so the norm of the vector PO is square root of 5. So which means that the unit vector that the unit vector that gives us the direction of the vector PO is going to be PO divided by its norm, right? So unit vector parallel to PO, that points in the same direction, points in the same direction as PO is just 1 over square root 5, comma, minus 2 over square root 5. Okay, and finally we just need to find the dot product, so which means that I need to take the first entry of this unit vector multiplied by the first entry of the gradient, which is -24, plus the second entry of this vector times the second entry of the gradient vector, which is 18, right? And that's the answer. And I guess since it is negative, it means that the function is decreasing.